The James Webb Telescope has discovered a rough galaxy with the same name as the universe. We are entering a brand new era of natural science. If the new data is correct, so this galaxy is older than the universe. This means that our understanding of space and time must be completely revisited. And we're really ready to restart the history of the universe. Have we expanded our knowledge boundaries? Incredible things are happening in science today. A revolutionary telescope has revealed a never-before-seen image of an ancient galaxy. James Webb. The range of space telescopes has finally revealed the first galaxies born shortly after the Big Bang. However, these stars are growing so rapidly, so that mathematically, their journey seems to have preceded the Big Bang. That's clearly not possible, because if the starting point existed 1380 billion years ago, then there was absolutely nothing before, or no Big Bang at all. It's the only way we currently know how to explain the existence of these ancient galaxies. But what about the origin of the universe? Since NASA released the first image of the sound hole from the SCARF telescope, young Harvard astronomer Rohan Meadows' team discovered the galaxy Glossy 13, which is about 13 in red. This galaxy was born about 300 million years after the Big Bang. Glass represents Guangshan Lens Magnification Space Investigation. This international astronomy project aims to find the oldest galaxies in the universe. Initially using attractive force, now using the latest images from the SCARF telescope. Data from this extremely ancient galaxy initially aroused skepticism from the international research community. But the measurement error can basically be ruled out. Class C13 undoubtedly existed 1340 billion light-years ago. It is one of the brightest galaxies discovered in the early universe. And showing strong signs of star formation, it may contain many young, massive stars. Belongs to the third generation of stars. These were the first stars in the universe. Huge, extremely bright, and short-lived. Due to its unique landscape agent, the SCARF telescope can break down the faintest light into individual frequencies. To analyze the metal content of these extremely distant stars, this confirms some strange phenomena. Because landscape analysis shows that the metal content of Glossy 13 is very low. This means that the proportion of heavy elements is very low, and the galaxy is clearly showing signs of a young week. And according to our previous models of galaxy evolution, the structure of this galaxy is very complex. The shape and brightness are both very beautiful. According to this model, this week should be billions of years old. However, since then, he predates the Big Bang. Researchers could have said that Glossy 13 was just a rare exception. But that possibility was ruled out, because this discovery is not isolated shortly after Glossy 13. Messy Star has been confirmed to be older. Astronomer Stephen Kolstein discovered him on the birthday of his daughter Macy, and gave him this special discovery as a gift. Pass a variety of testing procedures. The amazing age of this star has been clearly confirmed. It was determined that he existed 300 million years after the Big Bang, maybe even 270 million years, similar to Glossy 13. The massy galaxy also shows signs of high star formation rates and hydrogen metals. This again suggests that this is a young and extremely active galaxy. But it is highly organized. So much so that the journey of the massy galaxy can be traced back to before the Big Bang. 300 million years after the Big Bang, It is possible that only the original stars lit up the theoretical loose stars of the universe. Clusters and small groups like primitive galaxies may still exist. However, galaxies that already contained hundreds of thousands or millions of stars at that time does not match our standard astrophysical model, allowing Stephen Finkelstein and his team to discover more candidates for the week. At least a dozen more extremely ancient galaxies have been confirmed. The first deep space image may reveal hundreds of such galaxies. However, it will take some time to confirm these findings definitively. Soon after, the SCARF telescope continues to observe the second deep hole image. Show again. The situation in the young universe is not as promising as researchers had imagined. SCARF telescope confirms stars powered by dark matter. Since the first stunning discoveries of the Webb telescope, researchers have been working hard to find new answers. How to explain all this? The explosion never happened. The horse happened earlier. Or are stars and galaxies developing much faster than previously assumed? And in a completely different way, these are all possible answers. But any new answer must be compatible with the old astrophysical foundations. And that's what many experts believe chastity is. Our entire physics may be based on some false assumptions. In this context, the SCARF has made another exciting discovery. The three possible dark stars are all from the earliest days of the universe. This is another revolution in astronomy. This finding is particularly noteworthy because this is the first evidence that these celestial bodies do exist. These stars were identified by their anomalous radiation. This does not match the known properties of ordinary stars. Dark stars are theoretical objects long predicted by astrophysicists. But it has not been observed in reality. They're fundamentally different from the average star we know, because they're powered by dark matter, not nuclear energy. Dark stars were first proposed as purely theoretical about 15 years ago. These stars are thought to have existed about 300 million years after the universe's earliest Big Bang. Dark stars don't generate energy by flicking into an ocean. Instead, it is powered by the decomposition of dark matter. Dark matter makes up about 27% of the mass of the universe. It can't be seen directly. It doesn't emit or absorb electromagnetic radiation. So far, its existence is proved only by the attractive force effect on visible matter. If we now prove that these stars do exist with dark stars, we also indirectly prove the existence of dark matter, and its characteristics can be further studied. Dark matter is believed to be one of the key components of the universe. If we can understand its properties better through observations and discoveries of dark stars, we can reconstruct the structure of the universe. Dark stars are much larger and brighter than ordinary stars in the same forest. They can be 10,000 times more massive than normal stars. Much more massive. These stars may have played a hitherto underestimated role in the development of electricity and the universe as a whole. If they were the first sources of light after the cosmic dark ages, they may have had previously unknown effects on interstellar travel. Could be the key to understanding the rise of the impossible discovered by Weibo. Were Fritz Zwicky and Paul Dirac right? Who would have thought? Two long-forgotten researchers will become the focus of scientific attention again because of the discovery of hope far and near. Fritz Zwicky and Paul Dirac are two of the great physicists of the 20th century. Zwicky is best known for his work on dark matter. One of his little-known theories was the theory of fatigue light. Dirac made fundamental contributions to quantum mechanics and cosmology. In the 1930s, Fritz Zwicky studied the new group, especially the new group. He hypothesized that there must be an invisible mass that he called dark matter. Everything is a dynamic that cannot be explained by some attractive force. His theory of dark matter was initially controversial, but then it became part of standard cosmology. The fatigue light theory of taste agents is little known. The theory holds that light gradually loses energy as it travels through the universe. The increase in the wave field leads to the development of red ants. As for the commonly accepted explanation that the red shirt was caused by the expansion of the universe, the opposite is true. According to the theory of self-crisis, photons interact with myocardial anesthesia to cause energy loss. If we believe this scientist, then the concept of cosmic expansion may be an observational error if the light is red because of the fur. So all our calculations of the age of the universe and the age determination of the stars found by James Webb is likely to be wrong. Then our approach to the universe could be fundamentally wrong. Paul Dirac was a contemporary of the crisis. Studying quantum mechanics in the UK, developed the Dirac equation. The equation describes the behavior of fermions and predicts the existence of antimatter. Dirac further proposed, nature, which underpins all physical laws and interactions, is not necessarily constant, and it may change over the course of cosmic history. For example, according to Dirac's theory, the lotus root and the constant that determine the strength of the fundamental force may vary over time. That seems pretty unlikely in Dirac's lifetime. This idea doesn't make it into our standard astrophysics either. But now everything is different. We're taking old physics and we're not going anywhere. And cosmological discoveries are showing us more and more undesirable stars. The idea that natural quantities and natural forces can change over time is again accepted. Dirac's hypothesis on the variability of nature opens up the possibility that the laws of physics we observe today were not always the same. This could explain some of the anomalies in the cosmic microwave background radiation. It could also explain distant galaxies that don't fit the old path of the universe's gradual development. Canadian Research Institute Lendra Gupta was one of the first people to take the inferiority complex and the Dirac theory seriously. Again, he combined these theories. A new calculation on the age of our universe, 26.70 billion years. A second electron recalculated even revealed that the universe may be 40 billion years old or even older. If this is true, we may never see the beginning of the universe. In the coming decades, our technology may continue to improve, but there are certain principles of physics that prevent us from being able to detect much older light with telescopes. This is our last chance. Discover the true origin of the universe and how it works. We must find the same offensive. This God offensive will be the key to understanding all phenomena and forces in the universe.